Welcome to General Chemistry 2 class. This section is organic compounds focusing on example of polymers. In this lesson, we will give examples of polymers. Let us recall, based on the origin, polymers can be classified as natural or synthetic polymers. Natural polymers are made by biochemical processes occurring among living organisms, while synthetic polymers are man-made ones prepared from commercially available compounds. Examples of natural polymers. Polysaccharides, a type of carbohydrates made up of repeating sugar units, such as cellulose, the polysaccharide in plant cell wall. Proteins are polymers made up of several units of molecules called amino acids. An example is amylase, a protein found in saliva. Nucleic acids are made up of numerous units called nucleotides. An example is deoxyribonucleic acid or DNA. Natural rubber is a polymer of isoprene, a molecule that serves as precursor of a variety of natural products. The rubber is made by processing the latex or the white fluid produced when the bark of a rubber tree is sliced. Typically, rubber is soft and elastic, but its hardness can be enhanced through vulcanization, a process in which rubber is heated in the presence of sulfur. Vulcanized rubber are normally used in car tires. Synthetic polymers are also known as plastics. Plastics differ in the properties as a result of different monomers used to make these materials. A scheme is made to help plastic manufacturers and end users identify the polymer present in plastic-made materials. The Society of the Plastics Industry introduced the Resin Identification Code (RIC) for plastic-made materials. The codes are used to indicate the polymer making up a certain material. With these codes, manufacturers can easily segregate plastic-made products for recycling purposes. We will discuss some polymers corresponding to each codes. Code number 1, PET, polyethylene terephthalate, also known as PET or PETE, is a polyester prepared via step growth polymerization of terephthalic acid and ethylene glycol. This polymer is used in making plastic bottle suitable for containing liquids like water and soft drinks. Code number 2, HDPE, highly density polyethylene or HDPE is a chain growth polymer prepared by polymerizing ethylene gas in the presence of organic peroxides as the initiator and catalyst like the Ziegler-Natta catalyst. HDPE is generally a linear polymer. Branching sites in the polymer chains are few to nothing. It is used in manufacturing some plastic bottles and pipes. Code number 3. PVC, polyvinyl chloride or PVC is a chain growth polymer from chloroethene or vinyl chloride. PVC is hard by nature, hence used in making plastic pipes. In the presence of an additive called a plasticizer, PVC can be soft and flexible as observed in garden hose. Code number 4. LDPE, low density polyethylene or LDPE, is another form of polymer prepared from ethylene gas. Unlike HDPE, LDPE is highly branched as its preparation is carried out at high pressures and temperature. This polymer can be found in plastic bags and cling wraps. Code number 5. PP. Polypropylene or PP is a chain growth polymer of propene or propylene. This polymer forms materials with high endurance, thus suitable for manufacturing rope and furniture like plastic chairs. Code number 6. PS. Polystyrene or PS is a chain growth polymer of vinylbenzene or styrene. This polymer forms light, soft, and brittle materials, making it easy to be molded into different shapes. Cups made from polystyrene is beneficial in insulating drinks from the surroundings. Code number 7. Other plastics. Nylon is a polyamide that can be prepared either a diamine and a dicarboxylic acid or cyclic amide or lactam. Nylon 66, an example of nylons produced via step growth polymerization involving hexamethylene a diamine, and adipic acid, a dicarboxylic acid. Nylon 6, on the other hand, is a step growth polymer derived from caprolactam. Nylon-made materials have high impact strength. For instance, nylon 66 can be used in cap ply of car tires. Other nylons are used in manufacturing synthetic fibers and waterproof fabrics that can be used in jackets. Polycarbonates or PC are polymers containing the carbonate group. Lexan R is an example of polycarbonate prepared from bisphenol A and diphenyl carbonate. With its hardness, Lexan R is used in eyeglasses and safety goggles. Polyurethanes are polymers that contain the carbamate group. Its preparation, which occurs in step growth manner, can be done using a diisocyanate and a glycol. Polyurethanes are usually soft and elastic polymers which can be used as synthetic fibers. Synthetic foams can be obtained if the polymerization occurs in the presence of water. Biodegradable polymers. Polylactic acid or PLA and polyglycolic acid or PGA are polyesters which can be degraded by microorganisms. Copolymerizing lactic acid and glycolic acid are useful in manufacturing sutures in surgical operations. The PLA-PGA copolymer can be broken down into small molecules within weeks. The degraded suture are then absorbed and processed by the body. Adhesives. Methyl methacrylate and methyl 2-cyanoacrylate are used as adhesive known as superglue. Polymerization occurs when these monomers are exposed in moisture. Example, water vapor in the atmosphere. Upon polymerization, objects joined by the superglue will stick together. Polyvinyl acetate or PVAs is formed by polymerization of vinyl acetate. The soft and tacky nature of this polymer renders it to be used in making adhesives like paper glue and wood glue. Water-soluble polymers. In the presence of a base mixed with alcohol, PVAs can be converted to polyvinyl alcohol or PVA. PVA is a non-toxic, biodegradable, and water-soluble polymer. The reason why it has numerous applications in food processing and pharmaceuticals. For instance, PVA is added in eye drop formulations. To summarize, polymers are almost everywhere, from those we use in our day-to-day activities to those beneficial to our health and safety. These are references and bibliography. That's all. Thanks for watching.